Hi guys, so here in this clip, you learn about the SN1 and the SN2 reaction. So you see this very often in organic chemistry modules. I need to tell you what they mean. Now, the S's here represents substitution. The N here in capital represent nucleophilic. And later on, I will tell you what do the numbers 1 and 2 mean. Okay? So, as you know, nucleophilic substitution means that you must have an incoming nucleophile to kick out a leaving group. I will use shorthand for this, nucleophile, and to remove a leaving group. Let me just use LG to depict leaving group. Leaving, not with life, but it will leave the original functional group there. So for this example, I'll be using an alkyl halide, an RX, just for this purpose. Okay, R is an alkyl group, X is a halogen. Right. Halogen, that means we could have a chlorine, bromine, and iodine. Okay, we would not like to look at fluorine because it's of exception, so you just focus on these three elements here, chlorine, bromine, and iodine. Okay? Alright, good. So, suppose we have X. This is connected to hydrogen. And we have a CH3, CH3. Remember, this is a secondary alkyl halide. Why is it secondary? Because the carbon with the halogen group here is attached to only one other hydrogen. So it is secondary. Now in this case, the leaving group must be a halogen, could be either of these, and it could undergo possibly two different mechanisms in this nucleophilic substitution. The unimolecular and the bimolecular reaction, SN1 or SN2. Now because it's a secondary alkyl halide, it could undergo both pathways. I will show you the difference between these two. Now first up, we have SN1. SN1 means in the first step, only one molecule reacts. So this is the main molecule. It will just self-dissociate the bond here. It will just cut off its own bond to form the leaving group X minus and a carboxyl ion, a C plus with the rest of the bonds intact. Right? And then in the next step, the incoming nucleophile will use the lone pair and join to the carboxyl ion center. So eventually you will have the final product that you have used your nucleophile to replace the leaving group, that is your halogen. Alright. So all in all, you see there are two steps here. Step 1 and step 2. This is a SN1 reaction. Now for SN2 reaction, what happens is, straight away, 2 means in the first step, you have two molecules reacting. So the nucleophile will not wait for it to form a carboxyl ion, but rather, it will just bang in and push this out. look for my green color drawing. So over here, you will only have one step because in and out simultaneously, it is a concerted effort. So you just have a nucleophile by the side, and the rest of the bonds remain intact. Okay, can you see? The two methyl groups remains at the same location, is not touched. Right. So for SN2, there is only one step. It is a single step reaction. So now you understand the main difference between SN1 and SN2. SN1, two-step reaction, you form a carbocation. SN2 is a one-step reaction, you do not form a carbocation.